Okay, we have a piecewise function here. Let's close the door. First thing I'm going to do is look at this and realize these are really three distinct different functions, okay? So if I said f of x, I really mean y. Y equals 2x minus 1. So let's do this with color here, okay? If y equals 2x minus 1, I'm going to start down at negative 1. I'm going to rise up 2 units and run 1. Now I'm going to draw this in and then I'll adjust as needed here by the rule, the domain restriction, okay? So let's see if I go like this, draw my line, and I say, wait, this says it's only true if x is greater than or equal to 2. So I look up here, that's x is 1, that's x is 2. So I go like this. Since it said equal to, I use a filled-in circle, and I erase that. Okay, it's a little bit messy here, I apologize. Okay, so if we look again, that said that function if x is greater than or equal to 2. Okay, and then in red, we have a parabola. We have y equals x squared minus 3. Okay? Now, if you're not sure what that looks like, you can always make an xy or a t-chart, right? What if you said, what if x was 2? Well, 2 squared is 4, 4 minus 3 is 1. What if it was negative 2? Well, I get negative 2 squared is 4, 4 minus 3 is 1. And I can plot these points very nicely. So at 2, 1, and where am I now? Negative 2, 1. Oh, I'm sorry, I'm looking at the wrong one. I was wondering, like, that doesn't look quite right. I don't know where it is. Oh, sorry. So, 2 squared is 4. Okay, here we go. So I get 2, 1. And I got negative 2, 1. And it doesn't quite look like anything, so I look again. I'm like, well, what if I plug in 0, just for an idea? 0 squared is 0, minus 3 is negative 3. And if I have 0, negative 3, well, then it makes perfect sense what that was, right? So I get a little sketch to a graph here. Okay, pretend that goes up, and I'll do an arrowhead. I just know I'm going to erase in a second. So this now says, if x is greater than negative 1, so I go like this, it says greater than, so open circle on that line, which is really going to be right there. Okay? Let's see what happens here. We'll do a piece at a time here. So this says if x is greater than negative 1, non-inclusive, greater than negative 1, but at the same time, it's less than or equal to 3. So let me draw this out a little bit more. Pretend, I'm not perfect here, but I know it's going to be solid. Let's see if that makes sense. Less than or equal to 3. 1, 2, 3, and on the function itself. So I get x squared minus 3. Give me a nice parabola. Okay. If x is greater than negative 1, non-inclusive, greater than negative 1, but it stops at 3, inclusive. Okay. And let's try blue. Blue. Okay? Now we could still do the same method of checking it out there, but I don't think we have to now. Let's do 1 point just to make sure. What if we have x, y? Now I know what it looks like. It's just going to look like that. Well, let's just try a 2 to make sure. 2 squared is 4. 4 plus 2 is 6. So at 2, 1, 2, 3, 4, 5, 6. Did I count to 6 right? 1, 2, 3, 4, 5, 6. We did, didn't we? So we know it's going to look something like this. Okay? Then I look back at the restriction. Well, that just says if x is greater than or equal to negative 3. Okay? Greater than or equal to negative 3 would mean inclusive, right? So I'm going to go 1, 2, 3, negative. Pretend I'm drawing right... Oh, let me draw up there. Well, pretend it's right about here. You guys are neater than me, I know. Okay, now let's see what happens here. This just says greater than or equal to negative 3. Okay, well, 1, 2, 3, greater than or equal to, and since that went on forever, once it goes over here, that arrowhead would still exist. There's no other restriction on the domain there. Okay? Okay, you wouldn't have something harder than that right now on a quiz. If you could do that, you're doing wonderful. Okay? Good job.